Hello everyone. Today we will be doing a video on this topic thingy, and I'm gonna be doing a chemistry thing. Yeah. And I'm gonna try my best and become the best chemistry teacher ever in the world. But right now let's focus on some certain things. Let me see my grade. Oh my god. Okay. I understand how it is. But just letting you know guys, you can mean anything. Which means you can be anything. So let's get started. Okay, so one formula we can use to determine the amount of atoms in something is actually using Avogadro's constant. And you know this funny little number? 6.022 times 10 to the power of 23. Now let me say that again, you idiot. 6.022 times 10 to the power of 23. Now, other than that, we're gonna now go to let's do one example. I'm gonna give you an example. Let's say I have one helium and it has no, not one helium, one hydrogen, okay, and then I times it by 6.022 times 10 to the power of 23. We'll actually get 6.022 times 10 to the power of 23. So actually, kind of makes sense because you're timesing the the number of it, the actual number, which you only have one of hydrogen, even though that's not theoretically possible because it's actually a diatomic molecule. But other than that, it's pretty makes pretty much sense, and I think you can identify what it is. Now let's move on to this one. We have what a sigma. Uh, we have a plus times an mr. So let's say we want to get like the mr, the relative mass of of that thing, and relative masses are only like carbon 12, so you shouldn't be careful. Okay, let's give you one really good equation that you should use when you are dealing with mass spectrometry, which is a kind of sorcery that chemistry people like to use in their graphs. It's like a machine that I will go on to later. So in this mass spectrometry, you get like different elements, and now you have to get their percentages, and also don't worry about MZ. You have to get their percentages and times it with their atomic abundance. And once you get that, you have to divide it by either 100% or the total amount of the total amount of things that are inside the mass spectrometer. And by things I mean like atoms or ions or anything like that. So no, wait, yeah, the mass spectrometry won't have atoms because it's gonna be an ion anyways because they're gonna convert it into that thing. But we'll get onto that later. I'm just simplifying it and making it more complex for the reason of your understanding and the belonging of your reasoning. So